Hi, everyone. My name is Joe DePoe. I am a senior pre-sales consultant with Neo4j based in our London offices in the UK. And recommendations is one of the use cases I look after and one of the use cases I get really excited about. So today we're going to talk about graphs for recommendation engines, but we're going to try to look beyond the typical examples of recommendations. So we're all familiar with social recommendations, LinkedIn recommending people you might want to connect with, or Facebook recommending people you might want to be linked with or that you might know. In retail, Amazon, all online retailers really these days, making recommendations to you, things you might be interested in adding to your basket. And media, Netflix, Amazon Prime, Spotify, recommending content that you might be interested in. So we're all familiar with recommendations in the digital age in these ways, but maybe we're less familiar with the ways that recommendations might manifest in other industries, right? So today, hopefully, we'll convince you that whatever it is you do, whatever industry you work in, whatever kind of business you work in, you'll leave this talk feeling like you understand how recommendations might apply to your business as well. So we'll start by just doing a quick overview of recommendations as a topic, and then we'll discuss why Neo4j is such a good fit for recommendations and recommendation engines. We'll touch on the Neo4j recommendation framework, the property graph model, and the Cypher query language, because we're going to see a demo of these things later on. So just to make sure everyone's on the same page and we all understand the property graph model, how Cypher works, and how the recommendation framework works. Then we'll look through some different use cases, some in more depth than others, across the number of different areas, different industries where recommendations might come into play, and we'll wrap up with some Q&A. So at Neo4j, we like to say graphs are everywhere, and today we're also going to say that recommendations are everywhere. So we talked a moment ago about some of the typical use cases for recommendations in the digital age, things like retail, social, media, but recommendations really can apply in lots of different ways, right? So in healthcare, can you recommend the right treatment or the right intervention to keep someone healthy or to make them healthy when they become sick? Travel, much like retail, can you recommend travel packages, destinations that someone might be interested in? Job search and recruiting is another very interesting one. Can you recommend jobs to people based on their profile? Can you recommend ways they might upskill themselves so that they can reach their career goals, take the next step in their career through training and certification maybe? So there's lots of different ways that recommendations can apply outside of the typical examples that people might be familiar with. And not only are they recommendations applicable across industries, but within the enterprise, within a business, recommendations are also everywhere. So human resources is a really good example. Most large companies will have a human resources department. Human resources is a big topic, making sure that you can hire the right people, keep the right people, promote the right people. And manage maybe difficult people out of your organization or help turn them around. So HR is something we're going to talk about later in more detail. This will be the demo that we see. There's supplier analytics. Can you make recommendations, if you work with a lot of suppliers, make recommendations for how you might make the most effective purchases from them, what might be the right supplier to work with in a particular circumstance. And that could be based on cost, quality, volume, any number of factors could work into a recommendation like that. Personalization is another hot topic. So personal 360, understanding your customer. So a customer 360 is quite a common term, but it usually applies to a business having a complete view of their customer. This is more about how you can take that view of a customer and make their experience better. How can you hyper-personalize your service for them, hyper-personalize your offering, and make recommendations, for content or what their next step in their customer journey might be, based on what you know about them as a customer. The thing is, recommendations like that can be really difficult to make, right? It sounds easy. Recommend a product to someone, recommend some media to someone, but behind the scenes, there's really a lot going on, right? You might have some machine learning in play. You know, maybe if you're an online business and you have a lot of web logs, clickstream logs, you might do machine learning based on that. Certainly, you'll have a lot of data to work with regardless. Recommendations, you usually need to do them very quickly, right? In retail, for example, you know, you only have a few moments to build that screen and a few pixels in which to make an effective recommendation. So you need to be able to do it quickly. And there's a lot of things that you want to be able to take into account to make effective recommendations. The other aspect to this is kind of, there's two sides to a recommendation. There's the user perspective, the person who might be consuming your recommendations, and they're going to want things that are relevant to them based on their past behavior, similar users or similar customers to them, things that are related to what they're buying, what they're viewing, what they're working with. So you need to take into account the user perspective because you want your recommendation to be successful for them. But there's also your perspective, your business perspective. You want to make recommendations that also align with your business strategies, your goals. So this could be diversity. It could mean cost savings. It could mean increased revenue. You might need to factor in regulatory compliance into this picture. So your recommendations need to not only work for your customer or for your user, but also they need to align with your business needs, your business goals. And finding that balance is tricky, but very important. And this is why graph technology is such a good fit, because you need to take into account all sorts of different factors, right? You need to combine these things together to make an effective recommendation. So graphs really allow this hybrid approach to making recommendations, where you can weight multiple factors, multiple methods for making a recommendation and combine them together into something that's really effective. And this can take into account collaborative filtering, which is kind of very Amazon. You know, other people like you bought these things, or other people who bought the things you've just bought also bought this other thing. There's content filtering, which is based on, you know, metadata, user history, user profile, information about the content and about the user. Rules-based filtering, so these are you know, things you might want shown maybe during a particular season. If a certain thing is happening, then you want that to affect the recommendations. So you know, if it's winter time in London, maybe it's not so useful to recommend suntan lotion. And then there's business strategies. So again, these are taking into account your business goals, any regulatory compliance issues you need to deal with, you know, things that will drive the important KPIs for your business. So the graph allows you to combine all these things together in a way that other data models really would struggle more with. So Neo4j is a graph database. We just talked about why graph technology is a good fit for recommendations. So Neo4j allows you to traverse really highly connected data sets. And this is what you really need to be able to make these sorts of effective recommendations based on all the different factors you might need to weigh. You can combine these with graph algorithms, which we'll dive into a little bit more in a moment. But these are algorithms that we have published and released for use on Neo4j. Some big name stuff in there like PageRank, Betweenness Centrality, Louvain. So quite well-known algorithms. And these can be used to provide weighting and scoring in your graph, and then feed that into your recommendations as well. It's a really flexible data model. And the last point really is that it can help explain why you arrived at a particular recommendation. And this can be really important. You know, if you're making recommendations about, you know, who might be leaving your company, who might be a future leader, you don't want that to be a black box. You don't want to put some data into a black box and get a name out and not know how you arrived at that answer. So having explainability behind your recommendation is really crucial, and the graph can help you see all of the things that are feeding into your recommendation. So, in the context of an online business, for example, just because retail is such a common example for recommendations, and it gives us a kind of a common ground on which to explain them. Um, the recommendations framework in Neo4j can really help you improve your recommendations over time, right? So it's not just something you put together and you launch and away you go. Recommendations can be a journey. So you can start with a set of recommendations with a graph that represents your domain, your customers, your business. As you get more customer information in, that graph grows, you get more context. You can get feedback on your recommendations. Was this recommendation useful to you? Did people purchase the thing you recommended to them, or consume the media you recommended to them, or what have you. All of this feeds into the graph, enriches it, and helps make your recommendations better over time. You can combine that, of course, with machine learning or AI or some advanced data science techniques. And of course, you're always going to be monitoring and adjusting your recommendations. What works, what doesn't work. Maybe you do A/B testing, a champion challenger, where you try different recommendation approaches against one another. Whichever one works the best becomes the new champion, and then you refine over time, iteratively improving your recommendations. So Neo4j really supports that iterative self-learning approach to enhancing your recommendations over time. So a little bit about us. Neo4j, we are the #1 database for connected data. We are an enterprise-grade native graph database. And what this means is Neo4j is built for enterprise use cases. A number of retailers use Neo4j for real-time recommendations at massive scale, right? Black Friday scale. So we are scalable. We can handle large volumes of data. We are built for real-time use cases. We're ACID compliant, which means you can trust that your data is reliable. When you write your data to the database, you know that it's going to be there. Even if the database falls over for some reason, if you get a commit, you get a commit. So it's got all of the enterprise features you would expect from a proper enterprise database. And here's just a few examples from retailers, primarily in the recommendation space, just to give you more of a sense of the types of customers that we work with and the types of recommendations use cases we power and the results that our customers get from them. So you can see sales increase based on the use of recommendations. Response time using Neo4j is faster than using other types of databases. So, if you have a graph problem, a graph database is the way to solve it, and trying to shoehorn that into another data model or another database will be slower and less efficient in terms of hardware. So a little bit about the recommendation framework, which we'll see in a little bit. What this does is gives us a way to execute queries for recommendations against Neo4j in a very kind of logical, easy to understand way. And really what it does is it uses scoring to build the result set, and you build a recommendations algorithm, steps that you want to take, data that you want to include or not include as you build your recommendations. And it really follows kind of 4 main steps, which you can see here in the middle. And we'll see these in action in a little bit. But basically, you start with a discovery phase, typically, which is where you go to the database and find all the things you might want to recommend. And this could be, based on whatever it is your user is doing, something about their profile. These are the pool of things you might want to recommend. Then you have an exclude phase where you might want to take some of those things out. So you might want to exclude, if you were in retail, exclude things that are low margin or that you have low stock in. For whatever reason, you don't want to make recommendations of certain things. Then there's a boost phase. This is where you have an opportunity to resort the list of things you want to recommend. So you might want to move things up the list and recommend them first. Other things might be less important and you can move them down. And then diversity. So diversity, I always find, is quite useful in a retail context. You might want to mix up the recommendations a little bit so you're not recommending 25 of the same thing. Or you might want to throw in a few random things for serendipity, maybe things that are on offer or things that are new or very popular. Outside of retail, the use for diversity is sometimes a little less applicable. So, if you're recommending content to someone who's a researcher and they're looking for kind of interesting articles or interesting studies that might spark some new work for them, throwing in random stuff that may not be relevant to them at all probably isn't going to be very well received. So diversity as a step sometimes can be very interesting and very useful, and sometimes is less applicable. The idea is that we build this pipeline on top of your data, whatever your data domain is for these recommendations. So it's any kind of data that you might be getting from any of your systems. These recommendation pipelines can sit on top of that. And what this does is it allows kind of a faster time to delivery. It's easier to develop these pipelines, to try different things, to build different recommendation engines and compare them to one another. And you can do all of that through a UI without having to necessarily write another application for managing your recommendations. And we'll see that in action in just a little bit. I mentioned before our graph algorithms, so I'll touch on them here. There's over 35 of them now. We update them fairly regularly. You can see they fall into 5 main categories. So there's pathfinding and search. And anybody who uses Neo4j is familiar with the shortest path function, a very easy way to find the shortest path between 2 nodes by counting the number of hops. So the shortest path is the one with the least number of relationships. Whereas these pathfinding algorithms tend to work more in a weighted pathfinding scenario. So your shortest path might be the lowest distance, the least effort, the lowest cost, and these are things that you would put onto your relationships as weights, and then these algorithms can help you find the shortest path by that weight. There's centrality and importance. So some of these are really big names. I mentioned PageRank before, which was invented by Google. These are ways of finding important nodes in your graph, highly connected or very central nodes in your graph, or indeed even finding bridges between communities, nodes that sit between disparate communities and might be sometimes the only way that those communities fit together or communicate. So this can be used in a number of ways, finding things that are the most popular, the most highly connected. And maybe in our HR example, some of these things might be useful as well. You might want to take into account the central people in your organization who bridge different communities, who act as a conduit for information, and this might make them more important to your organization. So you would want to keep them and nurture them. Community detection. This is used for segmentation, looking for communities in your graph that naturally fit together. These could be social communities or any other kind of community, really, any group of nodes that naturally fit together. And you can segment your graph using these algorithms in a very automated way. Similarity, we'll compare nodes to each other, or indeed every node in the graph to every other node in the graph, and find the ones that are most similar. And this is not similar by kind of comparing text values or property values, but it's how structurally similar the graph around them is. So are they connected to the same things? Do they interact with the same other nodes? Is their behavior in the graph very similar? This can be used in a number of different ways. Can be quite interesting for making recommendations, looking for people who are similar to you, and then making recommendations based on what they've purchased or what services they've used. It's also great for data cleanup. So if you've got some messy data, maybe there've been some typos, and you think you have duplicate nodes in your graph, these can be quite useful for suggesting nodes that might be condensed into one. So helping with data cleanup. And then link prediction. So predicting whether 2 nodes are really connected somehow, should be connected or will be connected in future. So this is helping you to find implicit links, implicit relationships in your graph that are not explicitly defined. And again, based on the structural similarity of the graph around them. So if you're interested, there's a free O'Reilly book that you can download from our site. We wrote the O'Reilly book for graph algorithms, and that's available for free. Also, there's a link in the lower left, which will take you to the documentation for all these algorithms. So quickly, the property graph model. It's really made up of three different things. There are nodes, there are relationships, and there are properties. So in our example here, we have nodes, the circles. We have two nodes that are labeled as persons and one node that is labeled as car. Labels are just that. They're a way to label nodes to be able to work with them in queries, but they don't necessarily imply a schema in the same way that a table implies a schema for a relational database. So we can see the person on the left has three properties associated with their node. His name is Dan. He was born May 29th, 1970. His Twitter handle's @Dan. Properties are just key value pairs, and they can hold all sorts of different types of data. So here we have strings, we have temporal date types, we can have geospatial date types, and numbers, right? Any kind of data can fit in a property, basically. We can see the person on the right has a name property of Anne, and she was born December 5th, 1975. We don't have her Twitter handle, and that's okay. Like I said, a label doesn't imply a schema. So there's nothing that says all person nodes have to have a Twitter handle. You can apply schema constraints if you like, if that's important for your use case. But out of the box, there's nothing that says each node has to have the same types of properties. So this gives us a lot of flexibility, right? If we get Anne's Twitter handle later, we can add it. If we get her Instagram account, we can add that. It doesn't mean Dan has to have an Instagram account. Then there's relationships. So relationships sit between nodes and connect them. We can see Dan drives this car, which Anne owns. He has driven it since January 10th, 2011. So even relationships can have properties. But relationships always have one label, whereas nodes can have many labels. You can have Dan could be a person, he could be an American, he could be an employee, Anne could be a manager, she could be British. You can have multiple labels on a node if that suits your use case, but each relationship only has one label. You can also see relationships have a direction. So Dan drives the car, and that relationship goes in that direction, left to right. It wouldn't make sense for the car to drive Dan, right? But sometimes that relationship is, the direction of it is important. So every relationship is persisted to the database, saved to the database with a direction in one direction. We can see Dan lives with Anne, and we don't need to make a relationship in the other direction. It's kind of logically impossible for Anne not to live with Dan if Dan lives with her. So we just have the one relationship, and at query time, we can ignore the direction. Whereas loves is a more important relationship. So the direction of it is more important, right? So Dan loves Anne, and that's great, but we need to know that Anne loves Dan back, right? Because she may not. So in this case, they love each other, and that's great. We have two relationships, but it's important to know the direction of that relationship. And so in this case, we have two relationships, one in each direction. Then just a quick look at Cypher. So this is the query language that Neo4j has developed for working with graphs. It sometimes feels similar to SQL, but it is its own language, and it's quite specific to working with graphs and graph patterns. So we start with match, and match is the keyword like select in SQL for defining the pattern we want to match. It's meant to be quite visual. So because we represent nodes as circles, we draw nodes within parentheses in our query. Here's the label we're looking to match for our node. So we're looking for a person node, not a car node. And then in curly braces, we give the property that we want to match. So we're looking for a person node with a name property of Dan. Then we draw the relationship. So we can see we're looking for who Dan loves. And we indicate the direction of that relationship with the dash and the greater than sign. If we wanted to find out who loves Dan, we could take this greater than sign and move it over here as a less than sign so that the relationship moved left to right to left. And then we would find out who loves Dan. And if we wanted to know in both directions, we would just leave off that greater than sign. And with a dash at either end, we tell the database we're looking for that relationship in either direction. And then we give another node here at the end. We give it a variable name because we want the database to tell us who Dan loves, right? So we give this variable beloved, and then Anne's information will be populated into that variable, and we can work with it later in the query if we need to. So with that, we'll now dive into a few examples for recommendations. We'll talk about how recommendations apply across a number of industries. And then, of course, first we'll start with retail, again, just because this is a nice common ground. We're all familiar with recommendations based on similar products. So if you've looked at one thing, what are other products that are similar to it? Or indeed related to it. So if I'm buying a bed frame, maybe I want a mattress, maybe I want sheets, maybe I want pillows. There's recommendations for logistics. What are my options for getting this? Can I pay more to get it quickly? Can I pay less to get it more slowly? So on and so forth. I might want to filter based on some criteria. Maybe I'm most interested in particular brands, or I have a particular price range. And then there's automated bundling. So, putting 3 things together in a package that all fit together, your customer might want to buy that as a bundle, maybe with special pricing. Then there's HR. So this we're going to see a demo of. And there's some really interesting use cases for recommendations within HR, I think. First, we're going to take a look at flight risk. So can you recommend people who may be high risk for leaving your company? Then there's succession planning. So if this person does leave your company, who's the best person to fill that role? Can we recommend some people to take their position when they leave? If you're building a team, you might want to make sure that your team is cross-functional, that it's diverse, that it's got lots of skills, lots of different types of people in it. So you can make recommendations for how you build that team based on those factors. Of course, there's promotion and compensation recommendations. So, who might you want to promote? How might you want to structure your compensation and rewards? There's lifetime employee value. So this also factors, I think, into flight risk. So if someone is going to be leaving your company, can you predict, much like you would do in a retail scenario, what's your lifetime customer value? Can you predict the lifetime employee value? Is this an important employee to your organization? Will they add a lot of value in the coming years? And therefore, is it worth you investing in preventing or mitigating their flight risk? Otherwise, if they're a low lifetime employee value and you think they're at high risk of flight, maybe you allow that to happen, and instead you spend your time and effort in succession planning and nurturing someone else. So here are some example graphs, and again, we'll see a live demonstration of something like this in Neo4j of the flight risk in a moment. But here we can see if we were interested in spotting future leaders, here's some of the types of data you might take into account. So we have a colleague in the middle. This is Sally Superstar. We know some information about her education and her training. So she has an MBA, she got a BA, she got a first. She's done some training in anti-money laundering, some leadership training, some public speaking training. We know her employment history, KPMG to HMRC, Her Majesty's Revenue and Customs, and then a fintech startup. These may represent a pattern. Really, I guess what we'd be looking at would be someone else who may be looking at your leadership, or people who have been leaders in your organization who have been successful, and comparing their history and looking for people who have a similar pattern. I think the interesting thing that comes up here is the idea of bias. So recommendations are great, data-driven enterprises are great, but we need to be conscious that we can introduce bias accidentally into this process based on our data, right? So for example, if your CEO went to Eton, that doesn't mean that only employees who also went to Eton should be promoted, right? Some of this really requires some special care and some thinking about how you use this data so that you don't accidentally introduce bias and only promote people who meet certain criteria while ignoring other people who obviously could be contributing quite a bit to your business as well. Then we can take a look at things like mentorship history. So we can see here, she has a mentor here. named Joe Bloggs. There was another mentor here, Bob Jones. So are those mentors known for nurturing people in certain areas? You know, have they mentored a number of people who have gone on to be successful or not? The rating history, so she went from good to excellent, so that arc could be something you feed into your recommendation as well. There's some company activities she does outside of her day job, so she participates in careers fairs. She's developed particular skills. She's an expert in AML case handling, for example. And then we can see her role history. So she's got a current role here. She's a senior manager. She works for Jane Smith. Previously, she was an associate manager. She worked for Jeremy Johnson. So again, this pattern of roles that have been held can be indicative of a growth arc in someone's career, or as we'll see in the next example, that movement between roles might also be a trigger for flight risk. So if we're looking for potential leavers, we might be looking at different types of data, right? So here we have Tommy Trouble in the middle, our colleague. He has some HR complaints about bullying and working excessive overtime. There's a series of absences that have taken place. We can see his rating history from good to needs improvement to average. We can see his mentorship history, and he's had quite a few mentors, and so maybe that movement between mentors is indicative of some kind of trouble. And then there's also role. So we can see he was working previously in London for quite some time, maybe for about 2 years for Olive O'Brien. And then he moved to St. Albans and was only there for a year. That was his last role. So this pattern, we might look at this and say, okay, these are the things that led up to Tommy Trouble leaving or potentially leaving the company. Can we look for other people who have that pattern and intervene if we decide that's the right thing to do? And it's almost like a customer journey analytics, right? You do the same thing in retail or services industry. If you look for patterns that indicate someone is going to churn or leave your company, leave your business, and you watch for that pattern unfolding, and that way you can step in and intervene if you so wish. So now we'll take a look at that in action. We'll look at a demo. So here we have the Neo4j browser, and this is a metagraph that describes the data we're going to be working with. So really it focuses on a few key data types. So we have positions, and this is sort of the meta position, the definition of a position of a role. It could be located in a country, in a particular region. There are some organizational hierarchies built in here, so you might have different org levels and divisions that this position sits in, the function and sub-function it sits in. Is there a particular personnel area? So this really describes the position, the role that would need to be filled, including what other roles that reports to. So you have a chain, a hierarchy, as well as a salary grade. Then we have a position status, and this is kind of an instance of a position. So every time someone fills a position, we have a position status, right? And then that's linked to personnel, who's the actual person who fills that role, right? They could actively be in that role, or they could have historically been in that position. Then around position, we have a number of things that describe that particular instance of a position. What was the actual pay? What was the salary grade assigned for it, and what years was that role actually active? So we can start to build a historical view of both what a person, what roles they filled, as well as what was the history of that position, who filled it over time. Okay, now we're going to take a look at the recommendations framework. So here we have a number of engines. Some of these are for other demos, for recommending movies or products. Today we're going to look at the HR data, and we'll start with looking at ways we can recommend people who might be at risk of leaving. What's a flight risk look like for our company? So I mentioned before the discovery phase. So we're going to have a few discovery phases, 2 of them. First, we're going to look for people with recent manager changes. Right? So this is the cipher. We're looking for people with new managers, right? And these are managers who have been in their position for less than 50 days, right? So it's not just that you know, I have a new manager, but my manager is also new to their role, which could be indicative of a flight risk, right? Maybe I don't like my new manager, maybe I liked my old one. I don't think this one, if I don't get along with them as well, or I don't think they do their job as well, or whatever. And then we rate everyone we get back from that list with a score of 5. Then we have employees with poorly performing managers. So here we're looking for people who have managers who aren't performing very well, right? And again, that could be indicative of flight risk. They say people don't always work for a company, often they work for a person, right? So if you get along with your manager, that's great. If you don't get along with your manager, that's a strong reason for leaving the company. So here again, we're scoring, but what we're doing is subtracting the rating. So if they got a low rating, the score here will be higher. If they got a high rating, the score here will be lower, right? So we're introducing a bit of variability into that score based on just how poorly performing your manager might be. Then we move on to the exclude phase. So here we're taking people out of the list that came up during our discovery phases, and we're doing that based on their position in the company hierarchy, right? So these are people who nobody reports to them, and if they're at the bottom of the hierarchy in our business, maybe we're not as worried about flight risk, or we're not in a position to invest in that level as heavily. And so we're going to take them out, and we're only going to be looking at people who manage other people who are higher in the company hierarchy. And then finally, once we have that list, through to the discovery and exclude phases, we're going to boost certain individuals based on their performance. So people who perform better will get higher in the list, and therefore we'll be more concerned about them leaving. If we wanted to, we could add more phases. There's lots of other things we could factor into that list. So here we have a GUI that represents the outcome of that recommendation. So the person with the highest flight risk in our company here is Brennan Albrook. And he works in Brazil in human resources. We can see that's followed by Ram van de Velde. He is in the UK in marketing, and so on and so forth. So all of these individuals have come through the discovery phase, were not excluded, and then arrived at their position by that final boosting. Okay. Now we can take a look at our other recommendation here. So we can look at succession planning. So if those people leave, who would be the best people to fill their position, right? So again, we have some discovery phases. Here we have 3 discovery phases. First, we're going to consider employees who report to the same manager. So these are colleagues of the people who are at flight risk. They all report to the same manager. They're in the same group. Perhaps they're all suitable for filling this person's position. Then there's direct subordinates. So these are people that are managed by the people who are at flight risk, and they may be suitable for promotion into their manager's role. And then finally, I think, and quite interestingly, we look at employees who are following a similar career path. So this is looking outside of the management hierarchy for these individuals, and looking at people who have in their history a similar pattern of roles. So what we're doing is looking for all the roles, all the people who have shared a role in the past in common with the people who are at risk of leaving. And then we score them based on how many of the same roles they filled in the past. So this is collaborative filtering, I think, right? Recommend people who have a shared pattern of roles in the past to you. And then again, we have a boost phase at the end. We boost on performance. So we want to push people up the list who are already performing highly and make them higher first for consideration in our recommendation. So if we go back, we can see if we click on Brennan Albrook, these are the people that come up as being open for recommendations for filling that role. Here's Lisa Iplet. She is in Brazil. The others, Shepard Dimac, are not, like Belgium, Taibi, Aliki, they're in different countries. And so maybe this would be another factor we might want to consider in our recommendations. Look for people who are based in the same country. Not to say that someone wouldn't want to move from Belgium to Brazil, but perhaps you would want to consider local people first. So hopefully this gives you an idea of how you can use HR data to make these sorts of recommendations, right? And there's all sorts of other things we could do. We could recommend training to people. So if someone wanted Brennan Albrook's role, what sorts of skills do they need to build? What are their gaps in training that they would need to fill in order to be able to achieve that career goal, for example? There's any number of things that you could make recommendations for in HR. So moving on, Customer 360, customer journey recommendation. So again, this is looking as a business at your customers and making recommendations based on what you know about them. So can we predict lifetime customer value based on past behavior? Can we predict their churn score? Are they likely to no longer do business with us? What's their engagement level, their customer satisfaction score? What's the overall profitability and margin analysis for a particular customer? So all these things can be considered recommendations, right? Can you look at the data that you have and recommend a score that represents CSAT or churn or lifetime customer value? And then flipping that on its head, Personal 360, this is what you can recommend to your customers or your users based on what you know about them. And there's a lot of community building here, right? So can you recommend people connections? Can you recommend communities that someone may belong to? There's content recommendations, of course. What might they be interested in reading? What might be, if they're coming to you for advice, what might be the thing that you would give them in terms of advice or documentation? So lots you can do in the Personal 360 space. Product and BOM or bill of material recommendations. So these are really for manufacturing companies for the most part. It's about being able to optimize processes. So can you recommend parts or materials that may be functionally similar? And can you recommend which of those parts or materials you should go with and consolidate on? Inventory analysis fits very closely with that. So how do you optimize your inventory? Can you recommend what you might want to get in stock based on what you're going to need to produce? We have some very interesting use cases around that. Optimize plant assignment, vendor and supplier optimization, bottleneck analysis. So can you look at the graph and recommend spots in your process that may be bottlenecks and how you might mitigate those to release that bottleneck? So again, some very interesting ways that recommendations can play a part in manufacturing and product industries. And then finally, government recommendations. And these always I find very interesting. I've been lucky enough to do some government work in my history, in my past, and I've always found the projects to be really, really interesting because there's kind of a social aspect to it, a feel-good aspect to it, and also the use cases can be quite unique and really very interesting. So infrastructure investment, can we make recommendations on what infrastructure should be built, what infrastructure should be upgraded or maintained, and also how can you plan around that? So obviously when you're building infrastructure, there's an impact on the local community, on the area that you're building in. How can you mitigate that? How can you plan traffic around that infrastructure investment, that construction? What services can you recommend to your citizens, to the users of your systems and your organizations? Can you recommend persons of interest in kind of a criminal investigation type scenario? So can you recommend people who might have been involved in a particular crime, or people who you might want to speak to as part of a particular investigation? And then the last two, which we'll dive into a little bit more in a moment, offender rehabilitation. So this is the idea that when someone has committed a crime and they've served their sentence, they come back out into society. How can you help them to integrate back into society so that they don't reoffend? Because reoffending is bad for them, it's bad for society, it's bad for the taxpayer because it costs money to keep someone in prison. So rehabilitation of offenders, how can we make recommendations to help them not commit more crimes? An epidemic response. So this could be a response, I don't know, to the zombie apocalypse, right? But we're going to take a look at animal infections and how we can make recommendations on how to respond to infectious diseases in animal herds. So first, animal disease outbreak response. So here in our example, we have an animal here who has been diagnosed with a particular disease. Of course, there's a test to verify that disease. There's some symptoms associated with it. There may be a treatment. There may be antibiotics or something you can apply, or sometimes the animal needs to be culled. You can see this animal is part of a herd. That herd is kept at a particular farm. And here in the UK, in the not too distant history, there have been some really severe disease outbreaks that really affected the farming industry. And this is things like mad cow disease, or BSE, blue tongue bovine TB. And I think traditionally the approach was, well, we've got an animal who is sick. That animal is part of a herd. That herd's got to go, is going to be culled. Then we draw a circle around that farm and say, well, all other animals in that radius either also need to be culled or need to be quarantined, right? So taking a very kind of geofence approach, or geospatial approach to the problem, and just drawing a circle on a map and saying, we have an illness here, and we're gonna look at everything within this particular radius. And I think what the graph allows us to do is take a more informed approach to how that risk might actually manifest itself. So for example, we see the animal here who is sick. That animal might have been bought from a particular breeder who has sold other animals into other herds. So if this animal was recently bought within the window of infection, maybe we want to look at that breeder and the other animals that they've had, the herds those have gone into, and we can see how that risk for infection has now involved these herds here. The herd that animal belongs to might have shared grazing, so it might share a paddock with other herds, and so therefore those herds that share that grazing land should be looked at, can be tested for the same disease. If this herd has been transported by a company that has also transported other herds, maybe you want to look at those herds. Maybe there's a risk for infection from the transport facility or the machinery used. And then likewise, you might have another animal maybe that left this herd, was purchased by someone else, now part of that herd. And so you would want to take a look at all these herds that could be exposed to the disease that this animal has. And of course, you can follow that onward. So, this herd here may have shared grazing with other herds. So you can follow that chain of exposure risk for disease, and then take more intelligent decisions about where you want to apply your testing, where you might want to apply your quarantining. So hopefully that's an interesting case, and we can certainly think about how that could apply to humans as well, right? If you have a TB outbreak or influenza or something like that in humans, you could take a very similar approach to look at where someone works, where someone travels, and manage the risk for infection in that same way. Then there's offender rehabilitation. So what we have here is an offender. We know some information about them. So with the prison they served their time in, what their sentence was, their parole officer, whether or not they have a partner. my understanding is it actually turns out that if a man has a girlfriend or a wife, he is less likely to reoffend. But if a woman offender has a boyfriend or a male partner, she may be more likely to offend. Statistically, this has worked out. So some of these information points can be worked into our recommendations as well. This offender was convicted of a crime. We can see the victim of that crime. We can see that the offender was part of a gang. And then we can see some of the issues this offender might have. So coming out of prison and having committed their crime, they might be depressed or have mental health issues. They might need help getting housing. They might have substance abuse issues that they need treatment for, or maybe anger management or what have you. So based on these issues that they have, there might be a number of interventions which we can recommend. And there's a number of ways we can recommend those interventions, right? So one way would be to do collaborative filtering again, and say, well, other offenders have been helped by this particular intervention when they had this particular issue, and they committed the same type of crime. So looking for people who have a similar profile to you, what worked for them, and making recommendations based on that, right? So we can see there's a number of potential interventions here. There are other things we might want to take into account, right? So if this intervention is offered by this organization at 2 locations, we can see this location here is actually quite close to the area in which the victim of this offender's crime lives. And so we might not want to send the offender into the same area as the victim. So instead, we might want to recommend the intervention at this other location. And similarly, looking at the other side over here, because we know the offender is in a gang and that gang operates in a particular area, this intervention is offered at a location that's near that area. And so we might not want to send this offender back into their old gang's territory. Instead, we might want to send them to this intervention at another location, which is neither near the victim nor the gang. Right? So lots of things can be factored into the recommendations to achieve the optimum outcome for this particular offender.